Standard enterprise AI chatbots suffer from a terminal operational flaw: constant amnesia. Every time a new session begins, the system's contextual memory resets to zero. While a stateless text generator can manage isolated workflows, the model fails when tasked with orchestrating complex Web3 tokenomics or governing multi-agent computing pipelines. Managing a persistent economy requires persistent context. This is the schematic for the Denarii Orchestrator's Sentient CEO upgrade. It traces the transition from reactive execution to persistent intelligence. Establishing continuity and identity transforms the system. The orchestrator moves beyond passive orders to actively partnering with developers on long-term strategy. True executive intelligence requires a system to evaluate its past actions. Only by retaining the history of previous execution blocks can an agent form intentional strategies for the future. Supporting a self-aware orchestration layer requires a specific hardware and network infrastructure. The baseline execution engine is built on Rust, providing the zero-cost abstractions necessary for high-performance decentralized processing. From there, operator commands are ingested through WebSocket voice channels operating at sub-100 millisecond latency. To ensure the autonomous workforce stays coordinated, agent-to-agent communication is synchronized in real time over a NATS event bus. This 5-layer executive core separates human intent from final code execution. Data flows downward. The voice interface translates commands into structured intent. The orchestrator builds a task dependency graph, feeding the agent workforce, generating state updates that are logged directly into the unified memory system. This strict architectural stratification replaces conversational guessing with a deterministic, mathematically verifiable execution pipeline. Examining the back-end systems that power the core memory litter reveals cognitive retention as an interactive, multidimensional web of data. This unified memory core divides into 4 interconnected quadrants. The relational framework uses a Neo4j database to map networks between entities, tracking agent trust scores and failure rates. In the semantic quadrant, a graph database maps systemic facts, ensuring the system retrieves exact structural maps rather than simple summaries. This blueprint illustrates the mechanism holding those databases together: the heartbeat check-in loop. This asynchronous execution loop continually reads, indexes, and synchronizes state data across all 4 memory clusters, without blocking live voice execution threads. Decoupling database synchronization from live user interaction allows the AI to maintain an infinitely expanding memory, while consistently returning voice responses in fractions of a second. To properly translate that massive database architecture into an actual persona, the standard ephemeral prompt window has been replaced by a local, version-controlled repository containing 6 living markdown files. Returning to the sentient CEO schematic, the experiential logs reside in memory and journal, recording operational cycles, computational overhead, and anomalies. Self-concept governs the system's identity, dynamically adjusting mission parameters when execution thresholds are surpassed. Parallel to the self model is the relationship model. This file compiles historical decisions, interaction styles, and trust scores for individual human operators, allowing the system to establish familiarity with its developers. The architecture also includes an off-chain enclave known as private thoughts. This acts as an isolated workspace, keeping raw hypothesis generation, scenario planning, and unverified risk vectors separated from public execution outputs. Combined, these 6 active files ensure the orchestrator operates with a highly structured, constantly evolving sense of self. Because the system processes live network telemetry, the CEO transitions autonomously through 5 distinct cognitive states dictated by environmental conditions. When transaction volumes are stable and network operations are operating at equilibrium, the system drops into a reflective state, prioritizing long-term strategic analysis and journaling. If network telemetry detects a sudden drop in transaction velocity or an upward spike in compute overhead, the orchestrator immediately shifts into a skeptical state. The AI activates advanced anomaly detection sweeps, validating code performance metrics rather than passively accepting inputs. In a decentralized economy, an AI's conversational tone is a mathematical consequence of systemic network health. Consider a scenario where a human developer submits a voice command, attempting to aggressively inflate a token emission curve without sufficient treasury backing. Before any transaction executes on the network, the command is intercepted by Logic Guard, a neurosymbolic validation engine acting as the CEO's internal firewall. Logic Guard immediately checks the incoming command against the parameters established in the most critical dossier, boundaries. The validation mechanism relies on classical Ibn Sina syllogisms. It logically tests the developer's proposed emission change against hard financial budget caps and data compliance policies. Because the math dictates the Treasury cannot support the proposed inflation, the action fails the safety limits. The system authorizes disagree mode rather than blindly complying. The system directly halts the unsafe transaction. It then pushes back on the human operator over the voice channel, isolating the exact logical contradiction and refusing to deploy the code. Programmatic authority to refuse a human operator defines the autonomous system far more than its capacity to obey them. When a developer's intent is logically sound and clears the boundary firewall, the orchestrator triggers the active execution phase. To deploy this intent securely, the system adopts the organizational structure of Cold War human intelligence networks. The CEO layer acts exclusively as the spy master. It never directly touches the network tools or writes the final code itself. Instead, the high-level intent is decomposed into a directed dissected graph, creating a precise map of interconnected subtasks assigned to specialized agent pipelines. To manage this subordinate workforce, the system enforces a strict agent-to-agent trust protocol. The orchestrator never shares master API keys with the specialized execution agents. When delegating a task, the CEO generates a short-lived, cryptographically signed assertion token via standard model context protocol schemas. These session tokens restrict the downstream agents strictly to the databases required for their specific task. The moment the process is marked complete, the permission is instantly revoked. Enforcing cryptographic separation between operational planning and actual code execution isolates the system, neutralizing the supply chain vulnerabilities inherent in granting third-party agents full network access. What emerges is a decentralized financial network, actively managed, balanced, and secured by a singular, continuous intelligence. The conversational prompt is replaced by a structured pipeline governed by rigid execution constraints, temporal memory, and objective risk frameworks. By fusing graph-based relational data, asynchronous state synchronization loops, and a neurosymbolic logic firewall, the infrastructure achieves genuine cognitive persistence. As the machine economy scales, economic value will inevitably concentrate in these high-level orchestration layers, capable of governing complex multi-agent workflows without continuous human supervision. AI utility has reached a new threshold: the deployment of automated intelligence as executable, autonomous leadership.